Hi, girls. So I am going to talk you through question 5 on page 77 of applications of integration. I'm going to also upload an image so you can have a look at this image while I'm talking about it, okay? Just something I wanted to go over with you is this relationship between displacement, speed, stroke, velocity, and acceleration. There's a huge connection between the three, and you have to be able to go between them. So if you have, let's say, displacement and you want to find out the speed or velocity, you're going to differentiate. If you have the speed or velocity and you want to find out the acceleration, you're going to differentiate that, okay? If you want to go backwards, you're going to integrate. So if you want to go from acceleration to speed or velocity, you integrate. If you want to go from speed or velocity to displacement, you integrate, okay? So on this one, it says a body is projected vertically upwards with an initial velocity of 25 meters per second, and its acceleration is minus 10 meters per second squared. Just one sec. So the first question here says the body's velocity. Now, just remember, velocity is the same as speed. The body's velocity, find the body's velocity at any time in terms of t. Right. What are they asking for here? Because that's the hardest thing with these questions. It's not the actual doing it. It's what are they asking me to do? So they want you to find the speed of this object at any time. So they've given you its acceleration, which is minus 10 meters per second squared. To find the speed from acceleration, if you think back, you're going to be going, let's say, from acceleration up to speed. You're going backwards, you're going to integrate. You're going to integrate minus 10. So if you look at the image I have, if you integrate minus 10, you're going to get minus 10t. Now I'm putting t in. If you put x, I'm trying to think, it is in terms of t, so that's why I'm putting t as a variable. So it's going to be minus 10t plus c, because you have to bring that in. You don't know what that is yet, okay? Now, they gave you the initial velocity, which means the speed at the start of this. They've given you that on purpose because that means at the start of this, your time is 0. So what I'm going to do then, I'm going to be able to find this constant by subbing in 0 in place of t, in this function minus 10t plus c, and I can put the whole thing equal to 25 because they told me the initial speed is 25. Okay, so on the image you'll see initial velocity, I've written t is equal to 0, so minus 10 by 0 plus c is 25. So then c is 25. So your actual velocity at any time, or your speed at any time, is minus 10t plus 25. Okay, that's the answer for the first part. The second part says its height s above this point of projection at any time. I found this part difficult myself, okay, because you have to again read between the lines of what they're saying. So for this part, they want you to find its height, and that's okay. To find a height is a form of displacement. To find that, you're going to integrate the speed or velocity. So we're going to integrate the previous part of the question. So you can see I've written down the integral of minus 10t plus 25. So that bit's okay. So that, if you integrate it, becomes minus 10t squared over 2 plus 25t plus c. Okay, now we want to know what this c is, and it's actually in the question how we're going to find that out, because they've said that above the point of projection at any time. It's before, let's say, something has been fired up in the air. Its height here, is that what we're dealing with? Yeah, its height is 0 at a time of 0. So with your function, what I've done here is I'm subbing in 0 for t and also 0 in for s, which gets me c being equal to 0. Okay, so that's why I've written so c is equal to 0. So your height function here is minus 5t squared plus 25t. Okay, that's part II. Part III then says the time it takes to reach a maximum height. Now, this is going back to our differentiation. With differentiation, if you're asked to find the max or the min, it's always where your derivative is equal to 0. In this case, it's where ds dt, which I've written down, is equal to 0. So if you have your s, ds dt is equal to 0. Now, if you go and differentiate that, you get minus 10t plus 25, which actually we had found out before back up in part II or I. We've already found it, but if you did it again, you get the same answer. Now, you put that equal to 0. So minus 10t plus 25 is equal to 0. So minus 10t is equal to minus 25. So t is equal to 25 divided by 10, or minus 25 divided by 10, which gives you 2.5 seconds. So at 2.5 seconds, this is at its maximum height. So I'm just going to, if you picture it, let's say it started here, it's gone up in the air, maximum height is at a time of 2.5. Then it is going to go back down, okay? So the next bit is the max height then. So you're going to sub the 2.5, but you're going to sub it back into the function for height. So you're going to be subbing it into the function you found for part II. And when you do that, you get an answer of, I think it's 25 over 4. I'll double check that. And I'll have it written down. I don't know how I have it written down because I was doing this without a calculator. Okay, and the final bit then says the time taken to return to the point of projection. So if you think again about this, you can see the function itself, the s, it's a negative quadratic. So it's like, think of it like being a rocket or something. It's going up and it's going to go back down then, okay? So it started here and it's going to be back down at the bottom over here. So there's actually 2 points where the height is going to be 0. So what you're going to do is you're going to put your sorry, the time taken. Yeah, you're going to be putting your distance function, your height function, sorry, which is minus 5t squared plus 25t equal to 0, because if you think of it on a graph, you wanted where the 2 points, the heights are equal to 0. If you solve that then, and I have to upload a second image, you'll have minus 5t squared plus 25t is equal to 0. So if I go about factorizing that to try find the two values of t, I get, what way did I do it? I pulled out a minus 5t, and in the brackets then I have t minus 5, which is equal to 0. So then if I solve that, I end up getting t is equal to 0 and t is equal to 5. So we already had the t is equal to 0 because that's where it starts. T is equal to 5 means that it's gone up, and after 5 seconds it's back down where it started. Okay, so I hope this helps with these. Page 76 to 77 I have a few questions like these. So now that's my second question I've done out. I did 2 out for you. Did I do 2 out for you? No, I did. I can't remember which one I did before, but I did one of them, and that's 5 done. For this class, I want you to just try a few more of these and ask me any questions you're stuck on. And then tomorrow we'll start a thing called definite integrals, okay? Which is a really important lesson. So please tune in for that, okay? Sorry, that's my stomach rumbling.